Okay, so in this video we're going to integrate cosine of z minus pi divided by z cubed with respect to z, and it's in the contour C. Now C here is defined as modulus of z equals 1. So that's a closed contour with a strict inequality. It's basically the unit circle, which will look something like this. That's the real, that's the imaginary, where that is 1. So that is our contour. So we're integrating inside here. Okay, so now what do? We need to see that the singularities of this function here are when z equals 0. Obviously z cubed equals 0. Now just to be careful here, z cubed equals 0 actually has 3 solutions, of which they're all z equals 0. So what we can say is this is a pole of order 3. That's at z equals 0. So it looks like we're going to use Cauchys Derivative Formula, which would be a nice way of doing this integral here without actually doing any integration. So we can see that this is a closed contour, and it's enclosed in the whole of the complex plane, which is a simply connected region. So that's fine. Now what we need to do is work out how we're going to go about using Cauchys Derivative Formula. So first of all, we define f of z is this function here. And now we need another function, which is g of z, which basically is f of z, basically taking the limit as z approaches 0, which is where the pole is, which just leaves us with cosine of z minus pi. Okay, so now we've got that. So now how do we handle the Cauchys derivative formula? Well, we've got pole of order 3, so n will equal 3, and our k is our kth derivative, and then k is equal to n minus 1. So basically how we do this is 2 pi I over kth derivative, and we take the kth derivative of g. And we take the value for this function at our pole, which is 0. So we just call that alpha for now. So alpha equals 0. Okay, and that's our formula, what we want. And then this one, basically this is what? Integral on C f of z dz equals, this is what it equals. So now we've got all our information here, we've got our formula, let's just plug it in. So what we need now is 2 pi I divided by k factorial. Well, if n is 3, this is going to be 2, so 2 factorial is just 2. And then we'll multiply by the second derivative of g at 0, using this alpha here. Okay, well we can see the 2's cancel out, that's fine, but our next pressing thing we need to look at is to take 2 derivatives of cosine of z minus pi. So let's go down here. So g prime of z is basically cosine becomes minus sine, and then using the chain rule, z is 1, multiplying by 1 makes no difference, so it's just minus sine of z minus pi. Now we need to go again because we need the second derivative. So the second derivative of minus sine will be minus cosine, and again chain rule z minus pi is still 1. The input to the cosine or the trig function that we're taking derivative of doesn't change, so minus cosine of z minus pi. So now what we get is we can cancel the 2's out, we've got pi I times minus cosine of 0 minus pi. Okay, cosine of minus pi. So minus pi is over here. So what is the cosine of that? Well, cosine of minus pi is minus 1. So it equals pi I times minus 1. So minus 1 is just 1. So basically the answer is pi I. Okay, and that's our answer.